Hello ELM258 students. This is a demo video for Virtual Lab 4. In this lab, you're going to create 3 different systems that do the same functions as the 3 electropneumatic circuits that you built in Virtual Lab 3. The first one is a dual push button control, the second one a single push button where it automatically returns, and the last one is where you flip a switch and it should go back and forth automatically. So they're going to look like this in AutoSIM, and the difference in this case is we're going to use a PLC to create the function, and we're just going to wire up the inputs and outputs to the PLC. So there's going to be the dual push button control, the automatic return where we're going to be using the sensor, and the reciprocating motion. So let's go over to AutoSIM. So what I'm going to do, rather than starting from scratch, using the circuits from Virtual Lab 3, and I'm just going to save this before I do anything else. I'm going to go to File, Save As, and I'll just put this on the desktop. Create a folder called Virtual Lab 04. And this first one I'm just going to call PLC System 1 Dual Push Button, just so I can keep track of it, and then save it. So now I'm going to just delete some of the stuff I don't need here. What I'm going to do is I'm going to use the circuit that had actuator B because it has the components that I need. The cylinder with the 2 sensors, and it has the throttle control, the throttle valves for the speed control, and the actuator valve. So everything else I'm just going to delete. So actuator A, just going to select, delete. Actuator C, get rid of that one. And then I'll just move this one up to the top. And I'm going to just going to get rid of all this stuff and just keep the solenoid valves because I'm going to be using those. I'll just stick them up here for now. And the last thing I'm going to do is to I'm going to change this to actuator A rather than B. So change the label to B, both of the sensors. And the valve is going to be A plus on one side and A minus on the other, and then the 2 solenoids, A plus and A minus. So now we need to add the PLC, and so I'm going to actually move this over just a little bit, make more room for it. The PLC, if you go to add an object and down to other, I'm going to use the 16 input 16 output PLC with common, and it looks like this. So now we have to wire the solenoids to the PLC outputs. Now this PLC in AutoSIM, this PLC is, the outputs are on the top row and the inputs are on the bottom row. And this first one that's labeled C is a common. So whatever voltage I put on that is going to go to the commons of all of the outputs. So when an output turns on, it's going to connect that voltage to the output. So I have to put a voltage on that output, on that common pin. And so under electric, under power sources, I'm going to do the power supply 24 volts. Just need to rotate that. And connect that to the common. And so the actuators get connected to the first two outputs, output 0 to the, actually let me do this, I'm going to switch this, I'm going to make the A minus the first one, and A plus will be the second one. And then we need to connect the other side of the solenoids to 0 volts. So back to add an object, common 0 volts, rotate that, so those solenoids are now connected. Now I have to add a couple of push buttons to the inputs, inputs 0 and 1. Now this particular PLC is the inputs are fixed as syncing inputs, which means you have to supply 24 volts to make the PLC input go true. Now this 24 volt terminal here is actually a low current 24 volt supply that's designed to supply the inputs with 24 volts. So I'm just going to connect that to the common side of each of the inputs. So I'm going to need a couple push buttons. So I go to add an object. Under electric, we go to contacts, and down at the bottom is a push button, normally open. I'm going to open that, place that, and then rotate. That's going to connect to the first input, and I'm going to copy that, paste it. Now these are going to be my extend and retract buttons, so I need to label them. So double click, and under symbol, this first one is going to be EXT A, which means it's going to extend the actuator A. And the next one, I'm going to call it Retract, R-E-T-R-A. And so to connect these, one side of the switch goes directly to the input. The reason I put them so far away is we're going to add some other inputs here, and we need room to be able to draw the wires. So that's why it's done like that. And then the back side, the common side of the switches, connects to 24 volts. So we're just going to route this around like this. So that finishes the electrical connections for this part of the project. The next thing we need to do is to create the PLC program. Now I'm just going to save this before anything happens. Make sure you save every so often so you don't lose your work. So if you look at the outputs and inputs, they're numbered 0, 1, 2, 3, and so on. And when we create the ladder diagram, generally with a ladder diagram, you want to label the inputs and outputs on the ladder logic not with the address, but with the function, because it's a lot easier to understand. So what you need to do first is create a symbol table that associates the output addresses and input addresses with their associated functions. So to do that, we go to the symbols, right click, create a symbol table, and if I right click here and click add, the name is going to be the name I'm going to give the input. So let's start with input 0. That one is the EXT A, extend A. The associated variable is the name of the input, which is lowercase I 0. Now we're going to add for the next input, which is retra, retract A, the associated variable is I1, input 1. Now we have to do the two outputs as well. So add the name of the first output. Now I found out by trial and error that AutoSIM does not accept the minus sign, so I have to actually spell it out. A plus, A minus. So the first output is A minus, and the output number is lowercase o 0, and the second output is A plus. Again, I have to spell it out rather than use the plus sign. So 0, output 1. All right, now we are ready to write a PLC program. So to get the ladder logic program, you just click on Programs, actually right-click on Programs, click Add a New Folder, and I'm just going to call it Ladder Logic. You can call it whatever you want. And it comes up looking like this. Now we need to build some ladder rungs. So to do that, down here there's a thing called Palette. And if you click that, you get all these menu items, and what you need to do, you're going to get all your ladder things from the ladder elements or ladder blocks. So we're going to start with the elements because it has these complete rungs that are already built. And so if you want one of these rungs, you have to kind of select the whole thing, kind of click and drag. So what we're going to want for this first rung is just a simple rung with one input and one output. So we just do that, we drag that in here, and that becomes our first rung. So what's going to happen is when the input for the extend button goes true, I want the output for the extend or for A plus to go true. So how do I get those symbols on there? Well, down here at the very bottom, there's the symbol list. So all those symbols, the 4 symbols that we created, are on that list. So if I want the extend button, that's extend A, to be activated, to activate this ladder logic input, I just drag it over. And then when I press extend, I want A plus to be activated, so I drag that to this one. Okay, and we also want to be able to retract. So let's go back to ladder elements, take the same rung, one input, one output, go back to the symbol list. Now we're going to drag the retract input to that ladder rung input and the A minus to the ladder rung output. So there it is. That's all. I press the extend button, extend goes true, it makes A plus output go true, and it will then cause the solenoid to switch the valve position and therefore extend the cylinder. Same thing with retract. Okay, now that I have that, I can go back to the Simula and scroll down a little so we can see everything. And now we're going to run this. So the first thing we have to do is go to Program, Compile, and then Connect, Program Connect. Press the green play button, and then press the dynamic display, the soccer ball icon. And so if I press the extend push button, the cylinder extends. If I press retract, cylinder retracts. So what's happening is the hardware is just activating the input, and you notice when I hold the button down, the associated output goes true. That's being handled just by the ladder logic. And same thing with retract.